So let's just take a look at the nature of graphical representation. Crude way to get a graphical representation of an equation or an inequality in one variable, or two for that matter, is to plot points and see what the graph looks like. So how can we be certain that these points that we get give us an accurate representation? That's one question. And then, is there a more efficient way to figure out what the graphical representation of equations in two variables look like, which we saw was relations or functions. So let's start exploring equations and inequalities in two variables. You've already seen that our current knowledge is if you had an equation in one variable, x squared equals 4, that would be represented on a number line with -2 and 2 as solutions. If I wanted solutions to inequality in one variable, x squared less equals 4, that would represent set of all points between -2 and 2, including -2 and 2. So now, for example, x squared plus y squared equals 4, or x squared plus y squared less equals 4. Those are equations and inequalities in two variables. All points that are exactly 2 units away from 0, 0 create the equation in two variables x squared plus y squared equals 4 using Pythagorean theorem. And so that represents all points on this circle with center 0, 0. X squared plus y squared less equals 4 will be all points on the circle and on the inside of the circle. Because if you, for example, pick 0, 0, 0, 0, satisfies the equation x squared plus y squared less equals 4. Any point that you pick outside of x squared plus y squared equals 4, which is the circle, will not satisfy the equation. So that's one way of figuring out what the solutions to inequalities in two variables might look like. Well, what if instead of two variables, you have three variables? So let's say x squared plus y squared plus z squared equals 4. Then you will be in three-dimensional space. The equivalent shape of a circle in 3 dimensions would be a sphere. So x squared plus y squared plus z squared equals 4 represents a sphere of radius 2 and center 0, 0, 0. What about the inequality? X squared plus y squared plus z squared less equals 4. That will give you all points inside the sphere because all of those points are less than 2 units away from 0, 0, 0. Anything on the outside of the sphere will have distance of greater than 2, so they will not be points of the solutions to that inequality. So we already have a sense of how to do equations and inequalities in several variables. You plot all the points that satisfy the equation, which will give you a curve in 2 dimensions or 3 dimensions. And then you shade the region that is part of the solution. We will only focus on curves with 2 variables or inequalities in 2 variables. So analytic geometry is the study of geometric curves, and we investigate graphical representations of equations in 2 variables like lines, circles, and other curves, which we saw even before now as part of our discussions with relations and functions. So now we will focus on what to do to investigate graphical representations of inequalities in 2 variables, like lines, circles, and other curves. This will give you regions bounded by the curves. So first example is determine if the points below are solutions to the given equations or inequalities. Go ahead, try these problems on your own, and then we will come together and discuss it. Go ahead, pause the video and determine if these points, -2, 1, 2, 1, -5, 0, and 0, -1, are solutions to the equation y equals x minus 1. So assuming you've come back, let's take a look. We can plug in the coordinates x equals -2, y equals 1 into the original equation, and we see that we get 1 equals -3, which is a false statement So negative 2, 1 is not a solution. What about 2, 1? Do the same thing. Plug it in, and we get 1 equals 1. So it's true statement, which means 2, 1 is a solution. Negative 5, 0, 0 equals negative 5 minus 1, or 0 equals negative 6 is false, which will tell us negative 5, 0 is not a solution. 0, negative 1, same thing. Plug it in, you get true statement. So 0, negative 1 is a solution. So in other words, you can see points that belong to the line y equals x minus 1 give you a true statement, and the other ones give you false statements. So one way to determine all solutions to the line y equals x minus 1 are points that belong to that line. Points that are not on the line will not be a solution to that equation. What about inequality y greater than 2x minus 1? Are negative 2, 1, 2, 3, negative 5, 0, 4, negative 1 solutions to this inequality or not? Go ahead. Pause the video, see what you can do. All right, so here we have negative 2, 1. We end up with 1 greater than negative 5, which is a true statement. So negative 2, 1 is the solution to that inequality. And so would any point 2, negative 2 comma y, for where y is greater than negative 5, all those points would be solutions to this inequality. If you plug in 2, 3, we get a false statement. So 2, 3 is not a solution because 3 is not bigger than 3. Negative 5, 0, we get 0 greater than negative 11, which is a true statement, so is a solution. In fact, any point negative 5 comma y would be a solution as long as your y coordinate is greater than negative 11. 4, negative 1 gives us a false statement, so 4, negative 1 is not a solution. All right, so let's ask you to fill in the missing coordinates if you wanted the points to be solutions to y equals 2x minus 1. Go ahead and pause the video and see if you can finish it. Go ahead, you can do it. All right, so negative 2y, when we plug in negative 2 for x, we get y equals negative 5. So the missing coordinate has to be negative 5. x3, when you plug it in, you get x equals 4/2 or 2. So 2, 3 is a coordinate. The missing coordinate x is 2. For 0y, you get y equals negative 1. So 0, negative 1. And when x0, plug it in, you get x equals 1/2. So that tells you in this particular case that when you lock in one of the coordinates, the other coordinate is fixed. What if you wanted to know whether the points are solutions to inequality? Same thing, solve. So we have 2y. When you plug it in, you get y greater than 3. And so any point 2 comma y for where y is greater than 3 would be a solution. You can take y equals 4, 5, 4.1, 3.1. Any of those y coordinates would work to give you solutions to that inequality. All right, go ahead. You finished B, C, and D. Pause the video, see what you can do. Go ahead, you can do it. All right, we have x negative 1. And so x negative 1, plug it in, you get 0 is greater than x. So as long as your x coordinate is smaller than 0, you are good to go. So I can take negative 4, negative 1. I can say negative 1, negative 1, negative 0.1, negative 1. So infinitely many possible solutions are possible here. 0y gives you y greater than negative 1. So 0, 5, 0, 0, 0, 1. Those are all possible solutions. And for the last one, we get 1/2 is greater than x, so x is smaller than 1/2. -1, 0, -10, -100. Again, as long as the x coordinate is smaller than half, you have infinitely many solutions to this inequality. So for playing means we can, our crudest way that will be able to get us solutions to equations in 2 variables or inequalities is to plot points and check and see if there's any pattern. There are other methods that we will learn. If you take calculus or higher classes, it will give you more precise methods of curve sketching when you have curves that are not the standard functions or relations that you have seen so far. So let's start with testing points in the xy plane to see if there are solutions to equations and inequalities. Again, ordered pair is a solution if x equals a and y equals b. When you substitute it in the original equation, gives you a true statement. So graphing inequalities in 2 variables will require you to sketch graph of the equation in 2 variables first. And then if the points on this curve are part of your solutions, you would keep the curve a solid curve. If they are not part of your solution, you would make the curve dotted and then use test points below or above the curve. Check whether they are part of the solution or not. So that's pretty much what will be involved in graphing inequalities in 2 variables. So for example, y equals x. We have y equals x, plug in points. So when x is -2, y is -2, -1, -1, 0, 0, 1, 1, 2, 2. Those are points that satisfy the equation. So when you plot them, you get these points. When you connect, you can see it's a line. And so in this particular case, all the points on the line satisfy the equation y equals x. Any point that is not on the line will not satisfy the equation. So this equation, we already have known that it's a line. So what happens then if you replace this problem with the inequality? So again, you would sketch the graph of y equals x, and then what? Make the curve a dotted line or solid line. In this case, it's equal is allowed, so y equals x will be a solid line. And now you have to figure out which of the points above the line or below the line are solutions. So we will have to do test points. Let's do 1, 3. 1, 3 gives you a false statement. So all points above the line will not satisfy the inequality. All right, 1, -1 gives us a true statement. So that point is a part of our solution to the inequality. So all points underneath shaded will give us the solution. So any point in this blue region are your solutions. So not just 1, -1, but you can say -2, -4, 2, -10, 3, 1. Infinitely many solutions are possible. And so that's why we shade the region, because that is our solution set. All right, y equals x plus 2. Again, plot the points, connect so we know it's a straight line. So to do the inequality, let's just quickly review how x-intercept -2, 0, and 0, 2 are your y-intercepts. Remember how to find them? Replace y to 0 to get x-intercept, x to 0 to get y-intercept. All right, what about the inequality y greater than x plus 2? Go ahead, you try it on your own. We already gave you the graph of y equals x plus 2, and then now figure out what the inequality solution will be. Go ahead, you can do it. Assuming you've come back, we will sketch the graph. And so to get the line and then to get y greater than x plus 2, we'll have to do some dotted line because y equals x plus 2 was our line. So we have a dotted line because no point on the line satisfies the inequality. And then we'll do test points. And you can see that 0, -1 gives us a false statement, but 0, 4 is a part of the solution and gives us a true statement. So everything above the line will be part of your solution set. So infinitely many points are your solutions. If I wanted to list some other solutions, all you have to do, as long as you're in the blue region above the line, so -2, 3, -3, 3, 2, 10, and so on. All right, go ahead, pause the video, see what you can do to graph the solution set to y less than x squared. See what you can do. All right, we have that the curve is y equals x squared parabola, which we already know how to graph, and then plot points and connect. So there's our y equals x squared. If you want y less than x squared, all the points on the parabola will not be part of a solution, so we'll have to make the graph dotted. So doing test points, we can see that 0, 2 is not a solution, and 0, -2 is a solution. So we would shade all the points below the curve y equals x squared. And so we have infinitely many solutions. You can say 2, 0, 3, 0, -2, 0, -2, -5, infinitely many solutions here. All right, go ahead, try this one on your own. Go ahead. So we have our line. -1 is our y-intercept. -2/3 is our slope. So down 2 and over 3. So 1, 2, 1, 2, 3, and connect. So that's our line. Equal to is allowed, so the line will stay solid. Make our test points, and then we can see 0, 1 is not a solution. So everything under the line is our solution set. So infinitely many points is our solutions. All right, x equals 3/2 y plus 2. So x equals 2 is our x-intercept. And instead of rise over run, we have run over rise, up 2 and over 3, or over 3 and up 2, or left 3 and down 2. You can go either way to graph the line. So remember, the line doesn't always have to be written as y equals mx plus b form. If it's x equals, then 3/2 instead of rise over run is run over rise. And the 2 instead of being y-intercept is our x-intercept. So dotted line because it's a strict inequality. And then test points, which tells us that we have everything under the line. The line is dotted, is our solution set. So in summary, solutions to equations in 2 variables, plot points, plot the curves. So that will give you rise to a function or relation. And then to do inequalities in 2 variables, we have to then take the curve and make it dotted or keep it solid, depending on whether it's strict inequality or not, and then use test points to determine which points belong to our solution set, and then shade the appropriate region.